Have you ever noticed when you check your bank balance, see the temperature, split a bill, or even calculate your marks, you are using different types of numbers. But we just call them numbers. Today, I'll tell you that the numbers are not same. They belong to different categories, and each category exists for a reason. So let's start. Let's imagine these four real-life situations. You count 35 students in a class. I'm sorry for this example, but your bank balance shows rupees 0. Temperature in Shimla is minus 3 degrees Celsius, and you split rupees 500 among 3 friends. Have you noticed something? Each situation needs a different type of number. That's why we need a number system. So let's start these examples one by one. Situation 1. Counting students. So we have 35 students. We cannot have 35.5 students. Not possible. We cannot have minus 10 students. So these are called natural numbers. These numbers are used for counting. They start from 1. There is no 0 and there is no negative number. Situation 2. Bank balance shows rupees 0. Natural numbers don't include 0. So we extend the system. So it's 0, 1, 2, 3. These are called whole numbers. So the numbers which include all the natural numbers and 0 are called whole numbers. There is no 0 in natural numbers. So in whole numbers, we can say we have 0 and all the natural numbers. So including 0 means it becomes whole numbers. Situation 3. Temperature is minus 3 degrees Celsius now. So we need numbers less than 0. Other examples where we need numbers less than 0 are profit and loss, above and below the sea level, lift going to basement. So we introduce integers. Integers include all the negative numbers, 0 and positive numbers, and so on. So these are integers. So we have natural numbers that starts from 1, whole numbers starts from 0, integers include all the negative numbers as well. Now situation 4. Rupees 500 divided among 3 friends. So each friend gets 500 upon 3, which is equal to 166.666. So here we are using fractions. Any number which can be written in the form of P upon Q where Q is not equal to 0, that means the denominator should not be 0, is called rational number. Examples: 1 upon 2, minus 3 upon 5, 0.25, 0.333, so on. Here an important thing is, if a decimal terminates, that means it ends. So it's 0.25, so it ends here. That means it is a terminating decimal number. So if a decimal terminates or repeats, so these are rational numbers. These both are rational numbers because they can always be converted to fraction. Like 0.25, it can be written as 1 upon 4. 0.333, it can be written as 1 upon 3. So we can write these decimals as fractions. So these are rational numbers. There is one more part which is irrational number. Now let's go to geometry. If one side of a square is 1 unit, this is also 1 unit, this is also 1 unit. So Using Pythagoras theorem, this diagonal becomes root 2, right? So can you write root 2 as a fraction? No, because its decimal is 1.4142. It never ends. It never repeats. Same is the case with pi that we use in circles. Its value is 3.1415926 and so on. These are irrational numbers. Now understand the structure. Natural numbers is smaller than whole numbers. Whole numbers are smaller than integers. Integers are smaller than rational numbers. Natural number starts from 1. Whole number starts from 0. Integers include negative numbers, 0, and positive numbers. And rational numbers includes fractions also, which can be written as P upon Q. Condition is Q should not be equal to 0. Another important point is rational numbers plus irrational numbers are real numbers. So both rational and irrational are real numbers. So I hope the basic structure of the numbers is clear. So before ending, there are some quick questions for you. Is 0 natural? Is -5 a whole number? Is 2.345 a rational number? And is root 5 a rational number? Pause and answer. So next time when you see a number in the exam, you will know exactly where it belongs. Thank you.